Our next topic is piecewise functions. Piecewise functions are made up of pieces. They still have to be functions, so that means that on my graph it must pass the vertical line test. As you notice in our first example, f of x is made up of two pieces, each of which has its own restriction. These restrictions are going to help keep our f of x a function, meaning it will pass the vertical line test. The first thing I should do is graph both of the pieces. The first piece, x plus 5, is a line. I know that my y-intercept is 5, and my graph has a slope of positive 1, so it should be rising from left to right. However, I notice that it has a restriction. It tells me that x has to be less than or equal, or just less than -2. Therefore, I do not want all of those pieces, so I do not need them. I'm going to erase them. But since it's just the less than sign, this should really be an open circle. The next piece is a parabola. I know that it has a y-intercept of 3. When I plug in 0, I get 3. When I plug in 1, I get 6. When I plug in 0, I already did that one. When I plug in -1, I get 2. And when I plug in -2, I get 3. And now I notice that it is symmetric, that this point right here, -1, 2, must be my vertex. If I connect those, I notice that my parabola would be like that. However, I have a restriction. X must be greater than or equal to -2. Therefore, I don't want all values to the left of that, so I'm going to erase them. And since it's less than or equal to, I would fill in this circle. So it's now a closed circle. A closed circle will take priority over an open circle. As you can see, my f of x function is a function because it passes the vertical line test. So yes, it is a function. The next part asks me to evaluate this function at 3. 3 is greater than or equal to -2, so I should plug it into this function up here, or the second piece of that function. When I plug it in, 3 squared plus 2 times 3 plus 3 is 18. Notice that this is not on my graph, so I couldn't use my graph to figure that one out. However, the next one, f of -4, is on my graph, so I could use my graph to actually answer that question. I would go over -4, and then I noticed that my output is 1. I could also plug that into the first piece because -4 is less than -2. -4 plus 1 is 5, so I've done it both ways. The third one, f of -2, I could use my graph and I could go over two spots, and I notice that my output is 3. So that's using my graph. Or -2, if I wanted to use the piece of my function and plug it in, I would plug it in to the second piece because the restriction there is x is greater than or equal to -2. Again, -2 squared plus 2 times -2 plus 3 is 3. The second example is also made up of two pieces. Again, the first piece is linear and the second piece is a quadratic. In order to keep it a function, both of them have restrictions so that there is no overlap. When I graph the first piece, I know that my y-intercept is 1. I'm going to go up 2 over 1 to continue graphing that piece. Connect my dots. Then I notice that x has to be greater than or equal to 1. So I don't want that part of the graph. Since it is an equal to sign, this point will stay closed. The second piece, x squared plus 3, is a parabola. I know that when x is 0, I have 3. When x is 1, I have 4. When x is negative 1, I have 4. So 0, 3 is my vertex. And the rest of it doesn't quite fit on the paper, but I have a parabola. But I only want values where x is less than 1. So I only want those pieces. Notice that I also made this an open circle. Is it a function? Yes. My only questionable area is possibly this line right here in green. However, since I have an open circle, one's not included and one is included, so I am okay. So yes, it is a function. Evaluating, if I plug in negative 2, well, negative 2 is less than 1, so I'd want to plug it into the second piece of my equation. Negative 2 squared is 4. 4 plus 3 is 7. I could also use my graph. And actually, there should be a point right here to figure that out. F of 6. I would plug that into the first equation up here, or first piece of that function, because 6 is greater than or equal to negative 1. 2 times 6 is 12, plus 1, 13. The last one, f of 1. The first piece includes 1, so I would plug that into the first piece. 2 times 1 is 2, plus 1, 3. So f of 1 is 3. I could also use my graph to count over 1, and I would notice that I went up 3. For the third example, f of x is made up of 2 pieces, both which are linear. For the first piece, I know my y-intercept is 1, and I have a slope of negative 2. So I'll be falling from left to right. And I know that x is going to be less than or equal to 2. So I'm going to stop my graph down here in the fourth quadrant, and I know that it goes to the left. My second piece has a y-intercept of negative 4, and it goes up 5 and over 1. So here's my y-intercept, up 5 over 1, up 5 more, and over 1. I know that x must be greater than 2, so that's why I've just ignored the other points instead of erasing this time. And I know that I'm going to continue going up 5 and over 1. The question asks whether or not it is a function. Again, if I draw a vertical line test by the one place that I might question it, I can see that it does go through 2 points. However, the top point is not included. Therefore, yes, it is a function. Evaluating this function at f of negative 4. Since I didn't continue my first piece of my graph, it might be hard to look at the graph and figure it out. So instead, I'm going to plug it in to the top piece. Negative 2 times negative 4 plus 1 is 9. F of 8. Well, that I would plug into the second piece. Again, that's not going to fit on my graph, so I'm going to have to do it by hand. 5 times 8 minus 4, 40 minus 4, 36. For the third one, f of 2. This one I can do by just looking at the graph. When I go over 2, this piece up here is not included, so I want to use this piece down in quadrant 4, so when f is 2, my output is negative 3. Now is a good time for you to hit pause and try example 4 on your own, and then check your work with mine. Here is what your graph and answers should look like. Save questions 5 and 6 for class tomorrow. In part 2, we are now given a graph of the piecewise function, and we need to write out its pieces. For the first example, we have this piece in blue and our second piece in red. It doesn't matter the order that you write them in. I'm going to start with my f of x on the outside. I know that there are 2 pieces. The piece in blue has a y-intercept of 0 and a slope of positive 2. So the first piece is 2x. And I know that it is greater than or equal to 0. For my second piece, again, it has a y-intercept of 0 and it has a slope of negative 1. So as a linear y equals mx plus b, I would write that as negative x. Since I already included 0 in my blue piece, I'm going to write my restriction as x is less than or equal, just less than 0. I could switch it and say that the top piece would be x is greater than 0 and the bottom piece is x is less than or equal to 0. I can't make them both greater than or equal to and one less than or equal to, because then it would not be a function, because it would not pass the vertical line test. So I have to make sure that only one of them is included. For example 8, again we have two pieces. We have this blue piece, which should be moved over a little bit and go down one over one, and this red piece, which has moved a little bit when I copied it. So it should be up here on the 2. When I go to write this function, f of x with my squiggly bracket, for the blue function, if I were to continue this, I know it would have a y-intercept of 4, so I have plus 4, and it has a positive slope of 1. It is restricted for all values where x is less than negative 1. For my red piece, it is a constant with the y value of negative 2, and this is for all values of x greater than or equal to negative 1. Pause and try number 9, and then check your answer with mine. We will do questions 10 and 11 in class tomorrow.